Okay, again, a pretty simple one. A variable capacitor is set to 10 microfarad and connected to a signal generator set at a frequency of 100 Hertz. So it's just from the beginning, just remind ourselves 10 microfarad is 10 to the negative 6 micro. And let's look at the formulae for reactance of a capacitor. We've got it over here. Reactance of a capacitor is equal to 1 divided by 2 pi Fc. So reactance of the capacitor. Remember, reactance is the impedance against the current flow due to the capacitor. So it's the equivalent of the resistance of a resistor. It's the impedance, the capacitive reactance of a capacitor. So it's equal to 1 over 2 pi Fc equals 1 divided by 2 times pi times a frequency of 100 Hertz times a capacitance of 10 microfarad. That's 10 by 10 to the negative 6, which is equal to 160. And what are our units for reactance? Remember, it's impedance, it's a resistance, so the units are going to be ohms. Explain the two ways in which the reactance could be decreased. Okay, so here is our formula for reactance, and we want to reduce the reactance. We want to reduce the impedance, that resistance, as it were, of the capacitor. So looking at this formula here, we can see that 2 and pi are constants. We can't change in frequency. If we increase the frequency, then the reactance would decrease. So increase the frequency, or we could increase the capacitance. Increase capacitance. Either of those ways will decrease the capacitive reactance, and we'll see that's the exact opposite of the effect in the inductor. Explain what would happen to the reactance of the capacitor if the frequency is decreased almost to 0. So here's our formula again, 1 over 2 pi Fc. What happens if frequency tends towards 0? Well, we will have 1 divided by something something, 0 something something. Any number divided by 0 tends towards infinity. So we would say that as the frequency decreases to 0, then the capacitance will tend towards infinity. That's the answer to that. Okay. I just thought I'd add something to that. Remember how frequency and period are reciprocals. As the frequency goes to 0, the period for charging the capacitor goes towards infinity. So just think for a moment of charging a capacitor. If there's a limit to the amount of charge a capacitor can take. So if we're taking a very, very long time to charge it, then it's going to be very difficult for that capacitor to absorb it, which is why we would say that the reactance, the impedance, would tend towards infinity. So I think that makes a bit more sense.